Hi there, Lewis, Dan and Parry from Edera here, and this is a demo of the isolation that Edera Protect can provide you. So here you can see that I'm running a single node cluster with a node named Bronze, and I have two pods running in my namespace demo. I have Leaky Vessel and Raider. Now if we have a look at Leaky Vessel, we can see that we're passing through this environment variable here. Now if we have a look at Raider, we can see that we are passing through host PID is true and the security context is privilege true. This is essentially removing all the security defaults that we have within Kubernetes and also passing through the host processes from Bronze into a container within Raider. Now let's demonstrate why this is a problem, because if we exec into Raider, so we're going to spin up a bash shell. Now if I run ps-fo, I can see all the processes running on Bronze. Now if I grep sleep.sh, I can see that the process here is the process of a container within Leaky Vessel. Now, because I have access to the process, I can run cat proc, the process ID, environ, and we're just going to format it out so it's a little bit readable. And we can see all the environment variables. Now, two noticeable ones are up here of secret key and super orchestrator secret. So this demonstrates the attack that can occur when we're running containers next to each other. Essentially, there is no isolation. Containers are just processes running on the same machine. So let's clear this up, delete pods -all -force. Now we're going to show you how you can defend a workload such as Leaky Vessel. So if you've got a highly valuable container that's running and you want to defend it, you can use Edera Protect for that. So what we'll do is, for this demo, we'll run kubectl apply -file hardened vessel, and we'll run Raider as well. So whilst that loads up, let's do a diff of Leaky Vessel and Hardened Vessel. So we can see that the runtime class has changed to Edera, and we're also providing annotations for the kernel that we'd like to use, which is OCI compliant, and it's kernel 6.9, and also that we're going to give it 600 meg of memory. We've also changed the environment variable there. So if we do kubectl get pods, we can see that we have Hardened Vessel and we have Raider. Now if we look at the logs of Hardened Vessel, we can see that the process is running and that it is sleeping. So if I run kubectl exec -it raider -bash, we haven't changed anything within Raider. So if I run ps-fo, we can see all the host processes on Bronze again. But if I run ps-fo sleep.sh, I can only see the grep itself. I can no longer see that shell. So I can't identify the process because I don't have access to that process. So we are defending a workload using Edera Protect in that instance. So let's clean up our demo again. So let's delete pods -all -force. So we've shown you how to defend important workloads, but we can also defend untrusted workloads. So in this demo, we're going to apply our Leaky Vessel. And this time we're going to run Raider, but with Edera. So whilst that spins up, let's do a diff between Raider and Raider Edera. So here we see the change is that we're running it within Edera again, and that the kernel is 6.9 for annotation. Again, we are not changing anything within the container itself. We are not redeploying the container. We're not changing any configuration within Kubernetes other than just specifying the runtime class being Edera. So if we run kubectl get pods, we can see both pods are running. So let's run kubectl exec -it raider edera -bash. So now if I run ps-fo, I can see some processes, but I can only see what's within this container, even though it's still privileged and even though it's passing through the host process ID. So this is a way for us to be able to protect untrusted workloads when we're bringing them into our cluster. How do we achieve that? Well, within Edera, we have a concept called zones. Now, a zone is created just above the hardware. So, we have a hypervisor level above the hardware and before the operating system. So when you use Edera and specify that as a runtime class, we're creating new zones for your workloads. So here we can see that we had a zone already running in the default namespace for Postgres, which we were unable to view. But also there's our Raider. Now, as we have a zone on the hardware level, we can also dynamically update our resources. So we define for it by default to have a gig of memory. So we're going to update it to give it 4 gig. So if I run that command now, we can see that it's dynamically allocating additional memory into that zone, which is then available within the pod. As well as scaling up, I can also scale it down. Whilst this is happening, the pod is still running, the container is still running, the processes are still running. This is all happening within the zone, so we can dynamically update and allocate memory and CPU. So let's go back one step further. Let's SSH back onto bronze, and we'll do kubectl delete pods -all -force. For our last demo, we're going to apply leaky vessel. So if I run ps fo and I grep sleep, we can see the process running here, as we'd expect. So let's delete that, and let's apply a hardened vessel. And we will rerun and we can see that we're unable to see the process when we're SSH onto bronze. If I check the logs of hardened vessel, we can see that it is running and it is sleeping. And that's because the operating system that Kubernetes is within is also within its own zone. From this demo, I've shown you from the top down. I've shown you containers, pods, and an operating system hosted within a zone providing isolation. But at Edera, we're excited to share that we can also provide isolation from the hardware up. If you're using machine learning or AI workloads, then you're depending on GPUs. Now, the device drivers for those GPUs are currently being installed within your operating system. Using Edera Protect, you can install device drivers within their own zone. You can specify which zones have access to that device driver so that you can control and isolate GPU and other hardware at a zone level. All of this is written in Rust, and we pride ourselves on being as performant as bare metal or any alternative. Using Edera Protect, you don't have to lose performance by enhanced security. You can have enhanced performance with enhanced security. If you have any questions, please feel free to reach out. Thank you.